Okay, what we're going to do here, notice a couple things here. I've got the two equations from the last video right up here for our convenience. And what I was saying with the confidence interval, this value here, we called it, if you remember, a critical number. It allows us to make the confidence interval wider or more narrow depending on what we want. Now, if you remember, this is x bar plus or minus a standard deviations. That's the unit. Standard deviations, as I said, what if you talk to a buddy of yours and you said you're plus or minus 1.83 standard deviations, sure that something's going to happen or something's not going to happen. They're not going to know what you're talking about. So we're going to convert it. And the way we're going to convert this is we're going to convert it to something that people are familiar with, percentages. So what if I said I was 100% certain of something happening? Wow, 100% certain. Well, that would be like a confidence interval between minus infinity and plus infinity. Now, that's too big. We need to make it smaller, obviously. So how confident do we want to be? Well, the number I'm going to use first, I am going to use, this stands for confidence interval right here. I'm going to use a 95% confidence interval. The reason I'm using this is because when we look up what the Z value is, it's easy. That's the reason I picked this one. But you can pick any value you want for that. You could pick 82, 61.38, any number you want. Now, what numbers do our brains work well with? 5, 10, 15, 20, 25, 30. 10, 20, 30, 40, 50. That's why I want to pick numbers like this. Our brains work good with these 10s and 5s. Okay, so we'll be 95% confident. Now, what's going on here is I've got to look at the standard normal table. If I want to be 95% sure, I've got to find these values right here. Okay, if you remember, the normal distribution curve had 100% underneath it. There's 95%. So how much area are in these two tails? Combined, it's 5%, but they're split in half. This is symmetric. So over here, you have 0.025. Over here, you have 0.025. If you add that up, you get 100%. So what I'm going to do is I am going to go to the Z table and find this Z value here. Now, this is going to be negative because it's on the negative side. So if I want to know what area is to the left of that, I look up 0.025. Hopefully you remember how to do that. Now, I happen to have my table right here. If you don't have yours, please get it. So I'm looking around all in the body. And let me set this down. If you look, where is it? Right, the box there, the number right there. My finger's almost touching. You'll see 0.0250. That's exactly that number right there. That's exactly that number. That's why I picked 95% as my confidence interval for the first one we're going to do. The others aren't so nice. Okay, so look back at this again, and you've got 0.06 minus 1.9. So I'm going to write a couple things down. This is 1.96, actually negative, and alpha over 2 was 0.025. That's my level of significance. Let's give you another word here. Alpha over 2 of significance. I hope you can still see that. Yep, that's still on the screen. Okay. Now, something I want to point out. I've got the negative here because that's the way it came off of the table. But at this point in time, we're going to erase that. It could be plus, it could be minus. Hey, it's both plus and minus. It's already included in the equation. So we're going to write it down as a positive number. Now, what are some other good numbers to use? Well, there's two in particular that come up a lot. 90% and 99%. Those come up a lot. So we're going to find the critical values for those two. So we do it the same way. I'm going to redraw the whole thing. So what do I have? 90. So there's 0.90. So how much area are in the two tails together? Together, there's 10%. Half of that is 5%. So we're going to look up 0.05 and try to find that value right there. So please look in your table. I'll give you a little bit of time to do that. Now, what you're going to find is you're going to have a problem. And here's the problem right here. See that box right? Oops, going that box right there. That's where that number should be. That is where that number should be, but it's not there. So we've got 1.64 or 1.65. It's right in the middle of those two numbers. Well, we're going to put 1.645. It's right between 1.64 and 1.65, so I'm going to put it right in the middle. And I'm not taking the average of the two and just plopping it there. I'm getting this number from another source that you'll get to see soon. I'll show you that other source soon. I've got another table where these go up to an extra decimal. That would be a 0. This would be a 5. Okay. So that's where that is. Now, let's try 99%. 99% is going to give us a similar problem. So let's do this. We've got 0.99. So how much area is in those two tails combined? 1%. So if we chop that in half, how much is in here? 0.005, half a percent. So my level of significance here is 0.005. And now let's look up our critical value. If I go and look, and it happens to be right above my finger, that box right above my finger. Right there. Okay, let me put it right to the camera. This is so hard. Okay, there it is. It's 2.57 or 2.58. Hopefully you were able to see that on your own paper. I was not able to hold it very steady, unfortunately. So it's between 2.57 and 2.58. It would fit exactly in the middle, just like this number. So you're thinking 2.575. Actually, it's a 6. The normal distribution curve is a curve. It's not linear. That's why these numbers aren't, you don't just chop them in half. It's a little bit more complicated than that. Now, we can look up any number we want, and you can see that this is coming off of the standard normal table. So a couple of things that we're assuming here. We're assuming we got samples. We're assuming either our population was normal to begin with, or our sample size is larger than n, such that the sampling distribution is normal. And if that's the case, then this will give you exactly 99, the likelihood that the mean is in the 99% chance that the mean is in the interval that you create, or a 90% or a 95. It is still possible that your actual mean is out here, but it's very unlikely. That's what a confidence interval is. Now, I'm going to pause there, and then we'll do something else.